All right, last one about chemical shift. So we also have chemical shift of alcohol and amine. This proton signal of these functional groups are generally broad. We have 1 to 3 ppm for amine and 2 to 5 for alcohol. Okay. That's because of the strength of the hydrogen bond, but I'm not going to get to the detail. But I want you to look at to be able to identify that's the signal of the OH or NH. Okay, similar to IR. If you remember the signal peak, the peak of OH is usually broad. Right? Let's take a look at it on a proton NMR. Slightly broad. Look at that right there. Okay, depending on the solvent, this OH or NH are acidic proton, which means you can act as an acid, can exchange with a solvent, some type of solvent, like if you use like water as an NMR solvent. Okay, but anyway, so it's broad, something like that. So this, can you tell though where is the signal of the NH2 right here? You will see the broad one right there. Yeah, about 1 to 3 ppm. Be mindful that you should ignore this peak about 7.26. That's the solvent peak. Okay, so if you use chloroform D, which is most of us gonna use, yeah, we usually use chloroform D as a like general solvent. The peak of the solvent should usually show up at 7.26. So these are the peak that you should ignore. Okay, all right. So we have the whole thing in here. All right, you at least oh, I forget one thing. So at amine and alcohol, so it's broad, usually 1 to 5. So 1 to 3 for amine, 2 to 5 for alcohol. If this OH and NH attached to an sp2 carbon, it's go up to 5 to 10. They vary. All right. All right. So we have the whole chemical shift of proton NMR. So do not memorize any of this. You just have to use it often. Okay. Only one number I asked you to memorize is 3.7 for oxygen. All right. All right. I'm gonna help you be familiar with these numbers by doing sketch. We're gonna sketch together. Okay. All right. Let's look at on the next video.